Hi guys, Mr. Scrayback here, looking to start another exciting lesson on the life cycle of stars and how that ties into some of the basic chemistry that you guys learn in Fundamentals of Chemistry. Um, so last time we were talking about the life cycle of stars, right? And part of that life cycle that's really important to understand is that as a star is getting older, as it's moving through those phases, those protostar, main sequence, onto the red giant or red supergiant phases, and then all of a sudden it gets to those death stages, whether it's a dwarf star or a black hole. Because remember, there's two different paths. Depending on the star's mass, it could either become a black hole or it's just going to kind of fizzle out as a dwarf star. And that all kind of comes back to this idea of fuel and how much fuel that star is starting with. And when I talk about fuel, I'm really discussing hydrogen because all stars start with a core cluster of billions upon billions upon billions of hydrogen atoms. And to really understand what's going on inside a star, we need to go kind of back to those basics of atomic structure. And some of you might remember from Fundamentals of Chemistry, or some of you might not have taken it, but we'll get there, that the atomic structure has protons and neutrons in what we call the nucleus, the core of the atom. And then surrounding that nucleus are electrons. And it's those number of protons, that atomic number, that really determines what an element is. And that comes back to the periodic table. So if you can remember from the periodic table that there's those numbers in the top corner there. Hydrogen has 1 proton, helium has 2, lithium has 3, so on and so forth. And what defines the atom is the number of protons that it has. So hydrogen has 1. If you have 2 protons, you're no longer hydrogen, you're helium. If you have 3 protons, you're not helium, you're lithium. So in order to be an element, you need to have the correct number of protons. Hydrogen's got 1, helium's got 2, okay, carbon's got 6, and so on and so forth. So that's really important to understand, is that when you change the number of protons inside that nucleus, you are changing the atom. So essentially, as the nucleus gets bigger with protons, you're going to have a different element. So that's really important as you move into the lab that is posted on Google Classroom. Now that lab says to use marshmallows and black beans and white beans. If you don't have those at home, that's okay. Really, all you need is anything you can smush together to make a bigger and bigger thing. So for instance, I'm going to do a demonstration with Play-Doh, and I also have it kind of drawn on the board as well, but you can follow along at home with anything that you have, or you can just use the information that's going to be on this presentation. But I have some Play-Doh that I'm going to be using to kind of demonstrate this idea of a nucleus combining together to become bigger over time. Okay, so let's get into the lab. So posted on Google Classroom is a nuclear fusion lab. And as we look at the lab, okay, it tells you to kind of break things down into a couple of different components. So we have hydrogen. Eventually we're going to have helium and carbon. And then every nuclear fusion reaction produces energy, and there's even a little bit of a loss of mass, meaning that even though the nucleus overall is getting bigger inside the atom, there's a little bit that's kind of shot off in the process, and we call that a neutrino. So a little bit is lost and is creating energy when it's lost. So that's why stars have so much energy packed inside them, because nuclear fusion is such a explosive process that it creates so much energy that it can literally power a planet, an entire planet, through this process of combining elements to make bigger and bigger atoms. So let's get into how that happens. So let's say we have a protostar, right? Just a clump of hydrogen that comes together. The lab says to start with 20 hydrogens. So you can see up here that my little star shapes are going to represent hydrogens. So I'm starting off with 20 of those. Okay? If you're starting off in your lab, right, you can start with 20 little individual clumps of whatever you're smushing together. In my case, it's going to be Play-Doh. All right? So what you're going to do is you're going to take those little clumps, right? Let's put them onto a sheet, okay? Like lay them out just like this, okay? So here are my little clumps of Play-Doh. And what I want you to do is the first round of nuclear fusions is going to be taking care of this hydrogen. We're going to fuse these hydrogens, these singular protons. So each of these represents a single proton. So here's a little proton, and here's a little proton. Each represent a hydrogen. And what we're going to do is we're going to fuse them together. That's nuclear fusion, baby. There it is. Now we have a bigger atom. We have a bigger nucleus. We have combined our protons, but this is no longer hydrogen. This can't be hydrogen because there's only one proton in hydrogen. This no longer has one proton. It's two. So we've taken these two protons and fused them together. And by fusing those two protons together, we have created something new. We no longer have hydrogen. We have a helium atom. So I'm going to move this pair over to the helium. And if you're following along at home, that would mean taking the nuclei I just made, the helium nuclei, and just putting it onto that piece of paper. But when that fused, it created some energy. Zap. So we create a little bit of energy. So that's blue for energy. Okay. And there was a little bit of a loss of mass there too with what we call a neutrino. That little zigzag there is a little neutrino. So that was a little bit of loss of mass. Not enough to change the element that we created, but just enough where over time, with each reaction, we're going to lose a little bit more and lose a little bit more. So that is now my helium. So I'm going to put that over here on my helium paper or my helium box and leave that off to the side. And I'm going to keep going with hydrogen until I have no more hydrogen left to fuse into helium. So I would fuse my next two, and my next two, and my next two, my next two, so on and so forth until all of my hydrogen has now been fused into heliums. So that means I should have, in total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 heliums. Here I have 8. I need 2 more. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 heliums. Okay? So each of those is now a helium nuclei with 2 hydrogens inside of it. So that would mean that I have those 2 kind of bigger nuclei now. So each of these is a helium atom. And we're going to repeat the process. Also remember, before I forget, that each of these fusions, every single time these hydrogens fused, there was a little bit of energy released and some neutrinos released as well. So each of those reactions produced some energy and lost a little bit of mass. So now we're going to repeat that process, but instead of combining hydrogen to make helium, the star doesn't have any more hydrogen. We've used up all the hydrogen. So the star is moving into its next phase of its life. It's run out of hydrogen, so now the only fuel it has left to burn is helium. So we're going to take those 2 bigger nuclei, those 2 helium nuclei, and fuse them together. Nuclear fusion! Creating all this energy. Okay? And we have an even bigger nucleus. So that even bigger nucleus is being combined. Okay, so this is a new atom. And this is going to be a new atom. And this is going to be a new atom. And this is going to be a new atom. And this is going to be a new atom. Because those are all fusing together. Okay? So each time that those fuse, I'm creating now carbon. I'm creating a carbon atom. Okay? And by the end of this, you should have so many fusions to the point where you have a certain number of carbons that have been created. Okay, here I have 1, 2, 3, 4, 5. So I should have 5 carbons created. And, oh, I ran out of Play-Doh. At least that color Play-Doh, so I'm going to have to use a little bit other. So the idea here is that by the end, right, the next fuel source that the star is going to have to use, because it's run out of helium, okay, it's used all its helium to create some energy, 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 energy. And a little bit of loss of mass in each of these. The next, need one more carbon there. So the next fuel source is carbon. And the carbons are going to combine together to create an even heavier element. And an even heavier element. And the idea here is that over time, you're going to get a little bit of a remnant behind of some carbon left over that doesn't really have any other carbons to fuse with, but maybe this will fuse with this at some point. But the idea here is as the star is continuing to fuse and fuse and fuse and fuse and creating energy every single time, everything is going to combine into one giant nucleus. And at that point, the star doesn't have any more fuel to burn. And if a star doesn't have any more fuel to burn, it dies. And a star's life cycle is determined by what type of element is being burned inside the star's core. If you run out of hydrogen, you're moving on into your next phase. If you run out of helium, you're moving on to your next phase, and so on and so forth. So stars burn this fuel, and over time it runs out of a fuel source because what it's doing is combining all of these nuclei together. Okay? If you have any questions about the lab, if you have any questions about what is in your Google Classroom, make sure you're coming to office hours to pop in on Tuesdays, and I'll be happy to help you out. This lab can be a little tricky at first, but once you get the hang of it, it's a pretty easy demonstration. So feel free to email me. Stay happy, stay healthy, do your best to help each other and your families, and I hope to see you sooner rather than later. Bye, guys.